Welcome back. We're going to discuss the normal distribution, which we left off with yesterday, which is a type of distribution in which um, we have a symmetric bell shape type of graph. And but before we do that, I want to just kind of show y'all some real data that ties into what we're doing. So just to kind of give you an idea, we didn't do a test over this unit, but in the past I have, and this might have been last year or the year before, but here I have a histogram of my first period test scores alongside with a bar graph, so we can see there's an outlier there. We can see the maximum minimum. Looks like I gave probably bonus points for doing a review or something. We can see my 5 number summary, and we can see that the graph is slightly skewed left, maybe symmetric, but I think more type of skewed left, just because that 1, 2, 3, the fourth bar on the from the left to the right, um, but slightly skewed left. It's not, nothing looks perfect. We can go here and see the same thing. I'm not going to go through and spend a whole lot of time on all of these. I probably should have changed the bin size for this. I don't have that data still. This was my sixth period class, so look at how spread out this data is, and look at where most of like the IQR. I mean, yes, I did have a high grade of 105, but this is like, I think that this was a couple years ago, and my sixth period was just uh, knuckleheads, uh, so to speak. Um, by the way, I do want to draw your attention. If you ever do like if you ever do box plots in the past, it's like, or in the future, notice how this point right here, the line ends at that minimum value on the left, um, and so it looks like it's at 47. Uh, is the is well that 47 is not part of our 5 number summary, but that was our minimum. That was our lower bound, so I can't go past that. I would say anything from over here to that point, and then this point right here is our outlier. So, and I would show these to the class, and then obviously, I mean, I'm not saying who did what, but you can look and say, oh wow, I was that outlier, but that's not necessarily a good thing. Here we had 3 outliers in this class period. So looking at all of them kind of together, this is the box plots um, that we can see, and hopefully we should be able to see based off of this, like who did the best. I mean, all of them have like over hundreds. So what are we looking at here? I would say this one, looking at the actual spread of the data, first period was the most consistent. Their box itself, where the middle 50% is somewhere between like an 83 and a 95. So you had a good 50% there. Um, I would say who did the worst was sixth period, even though, oh no, all that's all the classes combined, first, fifth, sixth, and eighth. Um, so, anyways, that's kind of looking at data in real time. But today, that should say unit, uh, not 11. Hold on one sec. Let me change this while I'm here, so don't forget. I found this little thing, and I was like, "Oh, that's cute. That's the paranormal distribution." Too bad we don't do this during October. But what is the normal distribution, and why is it important? So the normal distribution is a big part of this project. It's actually, this part is worth more than the rest of the stuff, and this stuff is going to be done on poster because it's hard to kind of. I don't really know how to do this in a spreadsheet. Um, I want to have a nice curve to it, but the normal distribution is a type of distribution where most points cluster toward the middle of the range while the rest taper off symmetrically toward either extreme. These are a couple of examples. Here's one involving heights on the left, number of heads on probability, which we'll see this here in a second. So we looked at the probability of flipping a coin. This is a simulation of 20 times. Like you would imagine, if you flip a coin 20 times, the number of times you expect to land on heads is probably about 10 of those times. And then you're going to land, like it's very likely to land on 9 or 11 or 8 or 12 heads out of 20 flips. But it's less likely to land on 4 heads out of 20 flips or 1 head on 20 flips. So as we go further and further out to those 2 tails, the probability is less likely to happen. So we can see that. So it's bell-shaped, it's symmetric to the mean equals the median, and it's unimodal, mean it has just one peak to it. Just to kind of talk about a little bit about normal distribution in everyday life, these are some examples where the normal distribution appears naturally in places, like the normal distribution in everyday life involving height, which that's what my example has to do with height. You can look at all three of those, boys, girls, and both. They all look normal. Rolling a dice with probability, again, same type of thing. We talked about the highest probability to roll two dice is a 7, and then 6 and 8. So it's more common to roll a 7. The next common thing would be 8. You get this bell-shaped type of curve. IQ, same thing. You have this IQ where the majority of the mean is going to be like a 100, but then in that kind of middle section between 85 and 115 is relatively common. Shoe size would be considered normal distribution. Birth weight, same thing. Student performance, same thing. The stock market, same thing. So those are all like normal distributions. So recall from our probability unit with flipping a coin, and I just mentioned this a second ago, how likely would it be if we flipped a coin 20 times to land on heads 9 times? Like, and we're going to use these: impossible, not very likely, somewhat likely, and likely. Well, it should be pretty likely because half of 20 is 10, so that's pretty close to that. So I'd say that's likely. Landing on heads 10 times is likely. I would say 14 times is between likely and somewhat likely. 3 times is probably not very likely. None of these will be impossible. But I would have y'all do this coin simulation in class. So I'm not going to do it on the video, but just kind of show you what it looks like. And if you want to do this at home, you're going to click on the Delta Math assignment called normal distribution under this unit. You're going to select the number of flips as 20, and then you're going to hit the button to flip the coins, and you're going to write down the proportion in decimal form. So you have your calculator out if you need it, and then you're going to say 8 heads. So that if you got 8 heads and 12 tails, that's out of 20 flips. The proportion of tails is, you're looking at this in proportion of tails. So you would say you got 12 out of 20, which you get 0.6, and you type in 0.6. You're going to do this simulation 30 times, and then watch the shape. And it's really kind of cool when you do this in real time, because I have it pulled up in the screen at the front of the class, and it starts off just at a blank line, and then you start seeing everybody in the classes that's all synced up into one thing. So everybody's doing 30 simulations, and it just starts adding in based off of that probability of you happening. It kind of becomes a game too, because like there was a time whenever I got 3 out of 20 heads or 3 out of 20 tails, which was the only one, the lowest number for that entire day. So, because it's not very likely to happen. When the top of your simulation says 30, like, you can stop. But what we should observe from the simulation is what was likely should be clustered around the middle, and the data should taper off symmetrically as we get to somewhat likely and then not likely. This is just one example where collected data should appear normal and not skewed. Let's look at a few more real-life examples where the data would be considered normal. Actually, I already went over those. But here is a screenshot of kind of what it looked like during like last year, the year before, or something. I just put that up here. But you start with just this flat line, and then as each of you do a simulation, your result comes and pops up. Like, so if you end up getting 13 tails, you would see a coin float out from over here and land right up here. And if somebody else did that, it would stack that on top of that, meaning 2 people did. So each one of these is how many people did it. And you look, if we did it 20 times, we would expect half of those, since there's 2 sides to a coin. Look at the tallest one right here. It's at the 50% mark, or 10 out of 20. Okay. And then the next couple are right to the next to it. And so it just tapers off like that. And that's all we got for today.